Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Google Cloud Platform resources are managed hierarchically using organization, folders, and projects. When Cloud Identity and Access Management (IAM) policies exist at these different levels, what is the effective policy at a particular node of the hierarchy? The options are: Option A, the effective policy is determined only by the policy set at the node. Option B, the effective policy is the policy set at the node and restricted by the policies of its ancestors. Option C, the effective policy is the union of the policy set at the node and policies inherited from its ancestors. Option D, the effective policy is the intersection of the policy set at the node and policies inherited from its ancestors.
To arrive at the correct answer, we focus on the keywords, managed hierarchically, Cloud Identity and Access Management, IAM, policies, effective policy.
The correct answer is option C. The effective policy is the union of the policy set at the node and policies inherited from its ancestors.
Why is this correct? C. In GCP, IAM policies are inherited hierarchically and are additive. The effective policy at any node is the union of the policy configured directly on that node and the policies inherited from all parent nodes above it. Why are the others incorrect? A. Policies configured at ancestor nodes automatically inherit down the hierarchy, so the policy at a node is not determined in isolation. B. IAM permissions are additive and do not restrict access granted elsewhere in the hierarchy, unless deny policies are explicitly used, standard policies form a union. D. Because IAM permissions are additive, permissions combine as a union rather than an intersection of permissions.
You are migrating your on-premises solution to Google Cloud in several phases. You will use Cloud VPN to maintain a connection between your on-premises systems and Google Cloud until the migration is completed. You want to make sure all your on-premise systems remain reachable during this period. How should you organize your networking in Google Cloud? The options are: Option A, use the same IP range on Google Cloud as you use on-premises. Option B, use the same IP range on Google Cloud as you use on-premises for your primary IP range and use a secondary range that does not overlap with the range you use on-premises. Option C, use an IP range on Google Cloud that does not overlap with the range you use on-premises. Option D, use an IP range on Google Cloud that does not overlap with the range you use on-premises for your primary IP range and use a secondary range with the same IP range as you use on-premises.
To arrive at the correct answer, we focus on the keywords, Cloud VPN, on-premise systems remain reachable, organize your networking in Google Cloud.
The correct answer is option C. Use an IP range on Google Cloud that does not overlap with the range you use on-premises.
Why is this correct? C. Using non-overlapping IP address ranges between on-premises and Google Cloud VPC is required for Cloud VPN routing to work correctly without IP address conflicts, ensuring seamless communication across both environments. Why are the others incorrect? A. Overlapping IP ranges prevent VPN routing from accurately directing traffic, causing routing conflicts and rendering on-premises systems unreachable. B. Having an overlapping primary IP range creates IP conflicts and routing issues across the VPN, breaking connectivity to on-premises systems. D. Using an overlapping secondary IP range still causes IP address collisions and routing failures for traffic destined to those overlapping subnets.
You have found an error in your App Engine application caused by missing Cloud Data Store indexes. You have created a YAML file with the required indexes and want to deploy these new indexes to Cloud Data Store. What should you do? The options are: Option A, point Cloud Data Store create indexes to your configuration file. Option B, upload the configuration file to App Engine's default cloud storage bucket, and have App Engine detect the new indexes. Option C. In the GCP console, use Datastore admin to delete the current indexes and upload the new configuration file. Option D. Create an HTTP request to the built-in Python module to send the index configuration file to your application.
To arrive at the correct answer, we focus on the keywords, missing cloud data store indexes, YAML file, deploy these new indexes.
The correct answer is option A. Point Cloud Data Store create indexes to your configuration file.
Why is this correct? A. Using Cloud Data Store create indexes with your YAML index configuration file directly creates and deploys the defined data store indexes to your GCP project. Why are the others incorrect? B. Datastore does not monitor cloud storage buckets to auto-detect and deploy index configuration files. C. Deleting existing indexes is unnecessary and dangerous, and Datastore admin in the console does not support updating indexes via YAML file uploads. D. Deploying Datastore index files is handled using the Cloud CLI, not via HTTP requests to Python application modules.
You have an application that will run on Compute Engine. You need to design an architecture that takes into account a disaster recovery plan that requires your application to fail over to another region in case of a regional outage. What should you do? The options are: Option A. Deploy the application on 2 Compute Engine instances in the same project but in a different region. Use the first instance to serve traffic, and use the HTTP load balancing service to fail over to the standby instance in case of a disaster. Option B. Deploy the application on a Compute Engine instance. Use the instance to serve traffic, and use the HTTP load balancing service to fail over to an instance on your premises in case of a disaster. Option C. Deploy the application on 2 Compute Engine instance groups, each in the same project but in a different region. Use the first instance group to serve traffic, and use the HTTP load balancing service to fail over to the standby instance group in case of a disaster. Option D. Deploy the application on 2 Compute Engine instance groups, each in a separate project and a different region. Use the first instance group to serve traffic, and use the HTTP load balancing service to fail over to the standby instance group in case of a disaster.
To arrive at the correct answer, we focus on the keywords, Compute Engine, Disaster Recovery Plan, failover to another region.
The correct answer is option C. Deploy the application on 2 Compute Engine instance groups, each in the same project but in a different region. Use the first instance group to serve traffic, and use the HTTP load balancing service to fail over to the standby instance group in case of a disaster.
Why is this correct? C. Global HTTP load balancing natively supports cross-region failover between instance groups residing within the same Google Cloud project, ensuring high availability during a regional disaster. Why are the others incorrect? A. Individual standalone instances lack the automated management, health checking, and auto-scaling capabilities required for robust load balancer failover architectures. B. Failing over to an on-premises environment does not satisfy the requirement to fail over to another Google Cloud region. D. Google Cloud load balancers cannot route backend traffic to instance groups located in a different Google Cloud project.
You are deploying an application on App Engine that needs to integrate with an on-premises database. For security purposes, your on-premises database must not be accessible through the public internet. What should you do? The options are: Option A. Deploy your application on App Engine standard environment and use App Engine firewall rules to limit access to the open on-premises database. Option B. Deploy your application on App Engine standard environment and use Cloud VPN to limit access to the on-premises database. Option C. Deploy your application on App Engine flexible environment and use App Engine firewall rules to limit access to the on-premises database. Option D. deploy your application on App Engine flexible environment and use Cloud VPN to limit access to the on-premises database.
To arrive at the correct answer, we focus on the keywords, App Engine, on-premises database, not be accessible through the public internet.
The correct answer is option D. Deploy your application on App Engine flexible environment and use Cloud VPN to limit access to the on-premises database.
Why is this correct? D. App Engine flexible environment instances run inside a VPC network, allowing seamless integration with Cloud VPN to securely access an on-premises database without exposing it to the public internet. Why are the others incorrect? A. App Engine firewall rules only filter inbound traffic to the application, not outbound traffic, and exposing the on-premises database publicly violates security requirements. B. App Engine standard environment does not natively run inside a VPC network, making direct Cloud VPN connection without additional connectors impossible. C. App Engine firewall rules control incoming traffic to the App Engine application and cannot secure outbound traffic to an on-premises database.
You are working in a highly secured environment where public internet access from the Compute Engine VMs is not allowed. You do not yet have a VPN connection to access an on-premises file server. You need to install specific software on a Compute Engine instance. How should you install the software? The options are: Option A, upload the required installation files to cloud storage. Configure the VM on a subnet with a private Google Access subnet. Assign only an internal IP address to the VM. Download the installation files to the VM using SUDL. Option B, upload the required installation files to cloud storage and use firewall rules to block all traffic except the IP address range for cloud storage. Download the files to the VM using SUDL. Option C, upload the required installation files to cloud source repositories. Configure the VM on a subnet with a private Google Access subnet. Assign only an internal IP address to the VM. Download the installation files to the VM using cloud. Option D, upload the required installation files to cloud source repositories and use firewall rules to block all traffic except the IP address range for cloud source repositories. Download the files to the VM using SUDL.
To arrive at the correct answer, we focus on the keywords, public internet access from the Compute Engine VMs is not allowed, VPN connection, install specific software on a Compute Engine instance.
The correct answer is option A, upload the required installation files to cloud storage. Configure the VM on a subnet with a private Google Access subnet. Assign only an internal IP address to the VM. Download the installation files to the VM using SUDL.
Why is this correct? A. Enabling private Google access on the subnet allows Compute Engine VMs with only internal IP addresses to securely reach Google Cloud APIs and services, such as cloud storage, without requiring external IP addresses or public internet access. Why are the others incorrect? B. Blocking external traffic with firewall rules does not allow an internal-only VM to route traffic to cloud storage. Private Google access must be explicitly enabled on the subnet. C. Cloud source repositories is designed for source code version control rather than hosting large binary installation files, making cloud storage the appropriate service. D. A cloud source repositories is for Git code management rather than software installers. SUDL is for cloud storage, and firewall rules alone do not enable Google API access for internal VMs.
Your company is moving 75 terabytes of data into Google Cloud. You want to use cloud storage and follow Google recommended practices. What should you do? The options are: Option A, move your data onto a transfer appliance. Use a transfer appliance rehydrator to decrypt the data into cloud storage. Option B, move your data onto a transfer appliance. Use Cloud Data Prep to decrypt the data into cloud storage. Option C, install SUDL on each server that contains data. Use resumable transfers to upload the data into cloud storage. Option D, install SUDL on each server containing data. Use streaming transfers to upload the data into cloud storage.
To arrive at the correct answer, we focus on the keywords: 75 terabytes of data, cloud storage, Google recommended practices.
The correct answer is option A, move your data onto a transfer appliance. Use a transfer appliance rehydrator to decrypt the data into cloud storage.
Why is this correct? A. Transfer appliance is Google's recommended solution for offline migration of large datasets, typically over 20 terabytes. After the appliance arrives at Google, the transfer appliance rehydrator is used to decrypt and restore the data into your cloud storage bucket. Why are the others incorrect? B. Cloud Data Prep is an intelligent data service for visually exploring, cleaning, and preparing data for analysis, not a tool for decrypting data from a transfer appliance. C. Transferring 75 terabytes over the network using SUDL is slow, inefficient, and consumes significant bandwidth compared to offline appliance transfer. D. Streaming transfers with SUDL are meant for streaming output from processes directly into cloud storage, not for bulk migration of 75 terabytes of existing data.
You have an application deployed on Google Kubernetes Engine using a deployment named Echo Deployment. The deployment is exposed using a service called Echo Service. You need to perform an update to the application with minimal downtime to the application. What should you do? The options are: Option A, use kubectl set image deployment / echo deployment new image. Option B, use the rolling update functionality of the instance group behind the Kubernetes cluster. Option C, update the deployment YAML file with the new container image. Use kubectl delete deployment / echo deployment and kubectl create f-YAML file. Option D, update the service YAML file which the new container image. Use kubectl delete service / echo service and kubectl create f-YAML file.
To arrive at the correct answer, we focus on the keywords: Google Kubernetes Engine, Echo Deployment, minimal downtime.
The correct answer is option A, use kubectl set image deployment / echo deployment new image.
Why is this correct? A running kubectl set image updates the deployment's container image and triggers a Kubernetes rolling update. This incrementally replaces old pods with new ones, maintaining application availability and ensuring minimal downtime. Why are the others incorrect? B. Instance groups manage the underlying virtual machine nodes of the GKE cluster, not the application container workloads running inside Kubernetes. C. Deleting and recreating the deployment terminates all existing pods before creating new ones, resulting in significant downtime during the transition. D. Kubernetes service resources manage network routing and endpoints, not container images. Deleting the service disrupts access without updating the underlying application.
Your company is using BigQuery as its enterprise data warehouse. Data is distributed over several Google Cloud projects. All queries on BigQuery need to be built on a single project. You want to make sure that no query costs are incurred on the projects that contain the data. Users should be able to query the datasets, but not edit them. How should you configure users' access roles? The options are: Option A, add all users to a group. Grant the group the role of BigQuery user on the billing project and BigQuery data viewer on the projects that contain the data. Option B, add all users to a group. Grant the group the roles of BigQuery data viewer on the billing project and BigQuery user on the projects that contain the data. Option C, add all users to a group. Grant the group the roles of BigQuery job user on the billing project and BigQuery data viewer on the projects that contain the data. Option D, add all users to a group. Grant the group the roles of BigQuery data viewer on the billing project and BigQuery job user on the projects that contain the data.
To arrive at the correct answer, we focus on the keywords: build on a single project, no query costs are incurred on the projects that contain the data, query the datasets, but not edit them.
The correct answer is option C, add all users to a group. Grant the group the roles of BigQuery job user on the billing project and BigQuery data viewer on the projects that contain the data.
Why is this correct? C. BigQuery job user on the billing project allows users to run query jobs that are billed to that project. BigQuery data viewer on the data projects grants read-only access to the data without incurring job costs on those projects. Why are the others incorrect? A. BigQuery user role grants additional permissions to create datasets on the billing project, which exceeds the required minimum permissions provided by BigQuery job user. B. Assigning data viewer on the billing project prevents users from running jobs on it, while granting user role on data projects causes queries to be billed to the data projects. D. Assigning job user on the data projects allows users to execute and bill query jobs on the data projects instead of the central billing project.
You have developed an application using Cloud ML Engine that recognizes famous paintings from uploaded images. You want to test the application and allow specific people to upload images for the next 24 hours. Not all users have a Google account. How should you have users upload images? The options are: Option A, have users upload the images to cloud storage. Protect the bucket with a password that expires after 24 hours. Option B, have users upload the images to cloud storage using a signed URL that expires after 24 hours. Option C, create an App Engine web application where users can upload images. Configure App Engine to disable the application after 24 hours. Authenticate users via cloud identity. Option D, create an App Engine web application where users can upload images for the next 24 hours. Authenticate users via cloud identity.
To arrive at the correct answer, we focus on the keywords, upload images for the next 24 hours. Not all users have a Google account.
The correct answer is option B. Have users upload the images to cloud storage using a signed URL that expires after 24 hours.
Why is this correct? B. Signed URLs grant temporary write access to a cloud storage bucket, enabling external users without a Google account to securely upload files within a specified expiration window, such as 24 hours. Why are the others incorrect? A. Cloud storage does not support password protection for buckets. C. Cloud identity requires creating and managing user accounts, which adds unnecessary overhead and contradicts the requirement to support users without Google accounts. D. Cloud identity requires provisioning accounts for non-Google users, making it unsuitable for rapid testing by arbitrary external users.
Your web application must comply with the requirements of the European Union's General Data Protection Regulation, GDPR. You are responsible for the technical architecture of your web application. What should you do? The options are: Option A, ensure that your web application only uses native features and services of Google Cloud Platform, because Google already has various certifications and provides pass-on compliance when you use native features. Option B, enable the relevant GDPR compliance setting within the GCP console for each of the services in use within your application. Option C, ensure that Cloud Security Scanner is part of your test planning strategy in order to pick up any compliance gaps. Option D, define a design for the security of data in your web application that meets GDPR requirements.
To arrive at the correct answer, we focus on the keywords, General Data Protection Regulation, GDPR, Technical Architecture.
The correct answer is option D. Define a design for the security of data in your web application that meets GDPR requirements.
Why is this correct? D. Under GCP's shared responsibility model, GCP secures the underlying infrastructure, but you are responsible for designing your application, data storage, and access controls to comply with GDPR requirements. Why are the others incorrect? A. Using GCP native services does not automatically grant compliance. Under the shared responsibility model, the customer must ensure application-level data handling meets GDPR rules. B. GCP does not provide a single toggle or GDPR compliance setting in the console to automatically make services compliant. C. Cloud Security Scanner checks for technical web vulnerabilities like cross-site scripting, XSS, not regulatory or GDPR compliance gaps.
You need to set up Microsoft SQL Server on GCP. Management requires that there's no downtime in case of a data center outage in any of the zones within a GCP region. What should you do? The options are: Option A, configure a Cloud SQL instance with high availability enabled. Option B, configure a Cloud Spanner instance with a regional instance configuration. Option C, set up SQL Server on Compute Engine, using always-on availability groups using Windows failover clustering. Place nodes in different subnets. Option D, set up SQL Server always-on availability groups using Windows failover clustering. Place nodes in different zones.
To arrive at the correct answer, we focus on the keywords: Microsoft SQL Server, no downtime, data center outage in any of the zones.
The correct answer is option A. Configure a Cloud SQL instance with high availability enabled.
Why is this correct? A. Cloud SQL for SQL Server supports built-in high availability (HF) across zones within a region, providing automatic failover and continuous availability during a zonal outage with minimal operational overhead. Why are the others incorrect? B. Cloud Spanner is a distinct globally distributed database service and is not compatible with Microsoft SQL Server. C. Placing nodes in different subnets does not guarantee placement across different physical availability zones to protect against zonal outages. D. Self-managing SQL Server on Compute Engine requires complex configuration and operational maintenance compared to using managed Cloud SQL with native HA.
The development team has provided you with a Kubernetes deployment file. You have no infrastructure yet and need to deploy the application. What should you do? The options are: Option A, use Cloud to create a Kubernetes cluster. Use Deployment Manager to create the deployment. Option B, use Cloud to create a Kubernetes cluster. Use kubectl to create the deployment. Option C, use kubectl to create a Kubernetes cluster. Use Deployment Manager to create the deployment. Option D, use kubectl to create a Kubernetes cluster. Use kubectl to create the deployment.
To arrive at the correct answer, we focus on the keywords: Kubernetes deployment file, no infrastructure yet, deploy the application.
The correct answer is option B. Use Cloud to create a Kubernetes cluster. Use kubectl to create the deployment.
Why is this correct? B. Google Cloud CLI Cloud is used to provision the GKE Kubernetes cluster infrastructure, while kubectl is the standard command line tool used to create resources within Kubernetes from YAML deployment files. Why are the others incorrect? A. Deployment Manager provisions GCP infrastructure resources, whereas native Kubernetes deployment files should be applied directly using kubectl. C. kubectl cannot create a GKE cluster infrastructure, cloud must be used. Furthermore, Deployment Manager is not used to apply native Kubernetes manifests. D. kubectl interacts with an existing Kubernetes cluster to manage workloads. It cannot create the underlying GKE cluster infrastructure.
You need to evaluate your team readiness for a new GCP project. You must perform the evaluation and create a skills gap plan which incorporates the business goal of cost optimization. Your team has deployed 2 GCP projects successfully to date. What should you do? The options are: Option A, allocate budget for team training. Set a deadline for the new GCP project. Option B, allocate budget for team training. Create a roadmap for your team to achieve Google Cloud certification based on job role. Option C, allocate budget to hire skilled external consultants. Set a deadline for the new GCP project. Option D, allocate budget to hire skilled external consultants. Create a roadmap for your team to achieve Google Cloud certification based on job role.
To arrive at the correct answer, we focus on the keywords: evaluate your team readiness, skills gap plan, cost optimization.
The correct answer is option B, allocate budget for team training. Create a roadmap for your team to achieve Google Cloud certification based on job role.
Why is this correct? B. Building internal capabilities through targeted training and job role certifications addresses skills gaps cost-effectively, leveraging the team's existing GCP experience while aligning with the business goal of cost optimization. Why are the others incorrect? A. Simply setting a deadline does not establish a structured skills gap plan or a clear roadmap to address skill deficiencies. C. Hiring external consultants is costly and fails to optimize costs or build internal skills, while setting a deadline does not create a skill development plan. D. Hiring external consultants increases expenditure unnecessarily given the team's existing GCP experience, contradicting the cost optimization objective.
You are designing an application for use only during business hours. For the minimum viable product release, you'd like to use a managed product that automatically scales to zero so you don't incur costs when there is no activity. Which primary compute resource should you choose? The options are: Option A, Cloud Functions. Option B, Compute Engine. Option C, Google Kubernetes Engine. Option D, App Engine Flexible Environment.
To arrive at the correct answer, we focus on the keywords: business hours, managed product, scales to zero, no activity.
The correct answer is option A, Cloud Functions.
Why is this correct? A. Cloud Functions is a fully managed serverless compute platform that automatically scales down to zero instances when there is no traffic, ensuring no costs are incurred during non-business hours. Why are the others incorrect? B. Compute Engine requires managing virtual machines that incur continuous costs while running and do not automatically scale to zero when idle based on request traffic. C. Google Kubernetes Engine maintains running worker nodes that incur costs even when idle, as node pools do not automatically scale down to zero without activity by default. D. App Engine Flexible Environment requires at least one VM instance to be constantly running and cannot scale down to zero instances.